Okay, lesson 22 and 23 today. We're going to combine two lessons, and you'll notice that if you look at both the titles of lesson 22, they're the same: solution sets to simultaneous equations. And so we are going to look at it from a couple different angles. The first angle is, what is a system of equations? Okay, so a system of equations, in short, a system, what we're really looking for is a combination of an XY where two lines intersect. And today I'm going to show you two ways to solve for that system. The first way is going to be in lesson 22. It's called the substitution method. And then in lesson 23, they introduce something called the elimination method. And so we're going to have, in lesson 22, the substitution method. And we usually use this method whenever, for instance, we have y is equal to, say, 2x minus 3. Whenever y is equal to something, y is by itself, we typically will use the substitution method, as it allows us to immediately substitute and get one equation for one variable, that being x. However, sometimes it's easier to use another method, which lesson 23 we'll see in just a second. And that method is called the elimination method. And so these two methods we're going to use to solve systems to find where two lines intersect. So those are the two primary considerations for lesson 22 and 23. And then the third thing today is we're going to solve a system of inequalities. So we're going to kind of combine graphing lines and graphing inequalities that we learned in the previous lessons and see how that plays into simultaneous equations and inequalities. Okay? We're going to start by looking and going right to your textbook, your workbook. So here we go. Go to lesson 22, example number 1. It says solve the following systems of equations. And already we see that they're going to give us here initially a chance to see a third method, which is graphically solving this. So let's do the graphing of both of these, see what happens, and then we're going to actually do it algebraically using this concept of substitution. All right, so we know that basically we can graph this line. It's already ready to go. So I'm going to do that using my methods. The slope is here, and the y-intercept is here. And so I'm going to graph this line in blue. So I go to 1, and then I go up 1, 2, and over 1. 1, 2, and over 1. I can just keep that on 2 and over 1. And I'm going to keep doing that until I get a pretty solid look at my line. And so that's the blue line. It's not very straight, but you have a straight edge, and I would suggest, and this is part of the reasons why we need algebra, because you can tell right away that graphically, if I'm relying on this for accuracy, it's going to be very difficult. So the next line, I need to graph this. Now, one of the things I can use is instead of solving for y, I can use the intercept method to solve this by simply saying, well, if that's 0, I can plug in 0 for x. Plug in 0 for x into this one. And what do you get back? If you plug in 0 for x, you get back -7. If you plug in 0 for y, what do you get back? 0 for y, you get back 7. So here are my 2 points for the red line now. 7, 0, 1, 2, 3, 4, 5, 6, 7. And 0, -7. 1, 2, 3, 4, 5, 6, 7. Now the problem with this is when I go to connect, the problem with this is this is a big question mark. I don't know where exactly that's intersecting. And so now this is the reason why we need algebra to find the exact answer. And so we're going to use substitution to find that exact point. Show of hands who sees why graphing can be problematic. Okay, and so by using this concept of substitution, I'm going to take this y is equal to 2x plus 1 and x minus y is equal to 7. And I'm going to substitute the 2x plus 1 into the y. I'm going to substitute that into the y in this next part, and this is how it looks. So in blue, here's the solution. X minus parentheses. Every time I see a y, I'm going to put parentheses when I do this so I don't mess up. And then I'm going to put the 2x plus 1. I substitute in for y, hence the name substitution. And then I'm going to distribute. I distribute the negative through. Don't forget to do that. And then I'm just going to solve. And so the rest of it is just solving for x. Add like terms. And x is equal to negative 8. Now let's see. X is equal to negative 8. Does that look like negative 8? No. That's why graphing is not the greatest method. Okay, so the easiest way now to find y is going to be to substitute this x. Substitute this x right here into that part right there. Now I'm running out of room, so I'm going to do it up here. Negative 8. Negative 16 plus 1, and so y is equal to negative 15. So this point down here, this point technically is negative 8, and that makes sense. 1, 2, 3, 4, 5. That's about right. And negative 15. So this is where these two lines intersect, and that's what we have when we solve systems of equations using substitution. Graphing, very difficult to find the exact answer. Algebraically, we can find the exact answer. In this case, we use substitution. Okay? Now I'm going to shift gears now. I'm going to shift gears and I'm going to show you now how we solve systems of inequalities. So you guys got this? Good. You can always go back and look. So I'm going to fast forward, and I'm going to go forward here to this part right here. So we're going to go to example 2. So today, remember, there's 3 ideas. Solving equations, systems of equations using substitution and elimination. And then this is actually the second one, where we're asked to solve this system of inequalities. Now, we're going to do it the same way. We're going to use this concept of substitution, solving for y, etc. But this solution set is going to be slightly different. You're not going to have 2 lines intersect at one point. You're going to have intersecting areas. So let's take a look. So the first thing I want to do is I want to graph each individual. So I'm going to color coordinate this. I'm going to solve for y in this one. Oops, sorry. Solve for y, and I'm going to get y is greater than or equal to negative 3x plus 5. And then here, this becomes y is less than or equal to negative 3x plus 8. So all I did here was just move the 3x's over. So graphing this one then, graphing this means look at this number and that number. So positive 5, 1, 2, 3, 4, 5, right there. Negative 3, 1, 2, 3 over 1. 1, 2, 3 over 1. 2, 3 over 1. We're just graphing 1, 2, 3 over 1. Up 1, 2, 3 over 1. And it's equal to, so I'm going to do a solid line. And there that is. Now it's greater than here, and so I'm going to shade in blue. I'm going to shade here in a minute. Okay, I'm not going to do it yet though. Let's graph the red equation. Graph this now. Positive 8. 1, 2, 3, 4. No, 1, 2, 3, 4, 5, 6, 7, and 8. Same slope. Down 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3. You can see, we got a little parallel lines here. And then I draw this line here and notice that these are parallel. Although this says less than. Y is less than. Okay? Where is the solution set? Well, in blue, we're going that direction. In red, we're saying it's this direction. So the solution is actually here in the middle, where they intersect. The solution to this system of inequalities is where their regions intersect. Show of hands if you see that. Okay? Okay. So that's number 3, or rather number 2 here in the that's number 2 here in lesson 22. The second idea is graphing systems of inequalities. Now we're only going to do 3 examples today, one of each of the 3 primary ideas, and then tomorrow we'll come back and do practice. So now I'm going to kind of take a moment here, pause the video, and we're going to jump to lesson 23. So now in class, jump to lesson 23. Keep in mind, guys, that I'm just giving you 3 examples, and then tomorrow we're going to come back and do additional ones for systems solving substitution, more like this together, and more like what I'm going to show you next. No homework, but I'm just going to introduce these concepts. So let's now go to lesson 23. Boom. We're almost done.